Hello pre-calculus students, this is Unit 2, Day 2, and we are graphing sine and cosine and all the transformations today. Last class we built our first sine and cosine graphs from a table of values, and today we are going to write down those as our parent functions. So remember that this is theta on our x-axis, and on our y-axis, in this case, our y is going to equal the sine of theta. So from our table of values, we can say the sine of 0 is 0, the sine of pi over 2 is 1, the sine of pi is 0, the sine of 3 pi over 2 is negative 1, and the sine of 2 pi is 0. So we have one graph here. We're going to graph it with a smooth curve. And this is one period that we graphed here. The period is the length of one piece of the graph from 0 to 2 pi. And the amplitude is the distance from the midline to the top. So the midline is right here on the x-axis at the moment. So the distance from the midline to the top from 0 to 1 is a distance of 1. In our cosine graph, we still have our theta on the x-axis, and on our y-axis, the y is equal to the cosine of theta. So the cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is negative 1, cosine of 3 pi over 2 is 0, and cosine of 2 pi is 1. And again, you want to sketch in a smooth curve. Okay, the period, which is the length of one piece, is still from 0 to 2 pi, so that's a period of 2 pi. And the amplitude is the distance from the midline to the top, and the amplitude is from 0 to 1, so that's a distance of 1. Remember, both of these functions continue forever, so even though we're in the habit of just graphing one period, you could easily graph more than one period when you're given so much space. So here's more of my cosine, and I can graph more of the sine as well. Okay, down here we're going to talk about the shifts. We're going to talk about shifts and other transformations. So the amplitude is normally 1, but we can change the amplitude when we change the a value. The amplitude, though, is always positive, so we're going to say that the amplitude is the absolute value of a. The period of sine and cosine is usually 2 pi. But we can change the period when we change the b value, and so the period is 2 pi divided by the b value. What happens to the x happens inversely, so if it says x plus c, your graph actually moves to the left. And if it says x minus c, your graph moves to the right. Okay, the d happens to change your y's, to change them up and down, and it happens exactly the way you would expect. So if you have a plus d, then the graph would move up. And if you have a minus d, the graph would move down. If your a value is negative, that's going to flip the graph, and it's going to reflect, let's see, the graph reflects across the midline. Okay, in 3, we have a 2 in front of the sine, and that is the a value, so that changes our amplitude. So our amplitude is now 2. There's nothing in front of the x, so our period did not change. The period is still 2 pi. So this is a sine graph. Remember that sine is midline up, midline down, and midline again. So because my midline didn't change, it's going to start here at 0. It's going to go up 2, because that's my amplitude, back to 0, down 2, and back to 0. So here's one period of your graph. And you can draw more periods if you want. Just make sure they all have an amplitude of 2. Okay, moving on to the next page. Okay, in this cosine graph, the number that changes in front of the x, that's the b value, and that changes your period. So your period was 2 pi, but I need to divide it by the v value, and I get my new period is pi over 2. My amplitude did not change. My amplitude is 1. When I change the period, I don't want to have to try to smush my graph all in here into this little piece. So what I'm going to do is I'm going to change my x-axis. So I'm going to change my x-axis and I'm going to change my scale. Because my graph has essentially 4 pieces, I'm going to take my period and divide it by 4. So my new scale will be my period divided by 4. That's going to be pi over 2 times 1/4. So my new scale is going to be pi over 8. Alright, so let's go back and check that. I found that my period was 2 pi over 4, which is pi over 2. And then I divided that by 4, and I got pi over 8. So that means that this is going to be pi over 8. This is 2 pi over 8, which is pi over 4. 3 pi over 8. And 4 pi over 8 is pi over 2. My amplitude is still 1, so I'm going to start 1 above. So I start 1 above the midline, back to the midline, 1 below the midline, back to the midline, and 1 above the midline. Okay, number 5. In number 5, quite a few things are happening. There's a negative sign, which means it's going to flip across the midline. The 2 changes your amplitude so that your amplitude is now 2. And the 1/2 changes your period so that your period is 2 pi divided by 1/2, which is 2 pi times 2, which is 4 pi. So my period is 4 pi. I need to figure out what scale I'm going to use. So for the scale, I take my period and I divide it by 4. So my scale means every tick mark will count as pi. So this is pi, 2 pi, 3 pi, and 4 pi. Okay, my sine graph will normally start at the midline and go up, but it flipped, so it has a new pattern. The new pattern is midline, down, midline, up, midline. Here's the midline. Because my amplitude is 2, instead of going down just 1, I'm going to go down 2. Back to the midline, then 2 above, and then back to the midline. Okay, number 6. Alright, just about now things are starting to get pretty complicated. And when your equations get complicated, I'm going to suggest that you make a box. Let's make that note. When things get complicated, make a box. Okay, so looking at these transformations, I can see an x minus pi over 2, which tells me that my graph is going to move right pi over 2. My amplitude was not changed because there's no number in front of the sign, so my amplitude is still 1. My period was changed by this 2, So my period is 2 pi over 2, which is pi. I'm going to want to change my scale. So my scale is the period, which is pi. Scale is pi divided by 4, which is just pi over 4. So every box is going to count for pi over 4. So this is pi over 4, plus another pi over 4 is pi over 2, 3 pi over 4, and pi. And because I'm shifting right pi over 2, I'm going to need more numbers over here, so I'm going to continue on. Okay, so I need 1 here and 1 here. So then 5 pi over 4 and 6 pi over 4 is 3 pi over 2. Okay, I need to move right pi over 2, so this is my starting place here. If this is my starting place, count over 4 spaces, 1, 2, 3, 4. This is my ending place. My amplitude is 1, which means that my highest point will be 1 above my midline. I'm going to draw another line here. And my lowest point will be 1 below the midline. So my graph is going to happen inside this box. Sine starts on the midline, and then it goes up, back to the midline, then it goes down, and back to the midline. Here's my curve. Okay, next one. This time the 3 has changed my amplitude. There's no number in front of the x, so my period has not changed. My period is still 2 pi. And since my period is still 2 pi, I can still mark my x-axis with pi over 2, pi, 3 pi over 2, and 2 pi. This time I'm shifting left pi over 4 and down 1. So to shift left pi over 4, it's not quite negative pi over 2, it's going to be right here in the middle, negative pi over 4. And if I start half a box before 0, I'm going to end half a box before 2 pi. If I start early, I'll end early. My amplitude is 3, which means it's going to go up 3 from the midline. So my maximum point will be here at 3. 1, 2, negative 3. And then my graph will happen inside this box. So cosine starts above the midline. So I'm going to start here above the midline. Notice I'm between the tick marks, and that's going to happen for every point on this graph. So then when I go to the midline, it's between the tick marks. And then when I go to the minimum, it's between the tick marks, back to the midline, and then right here. So it looks like a V, but remember to put in the curve. That's your rainbow. That's your rainbow. And then draw your bowl. Okay, next page. Okay, the box method is going to continue to help us here. So we see we have a flip. The negative sign is going to reflect across the midline. The 2 is going to change our period so that our period is 2 pi over 2, which is just pi. And we're going to shift right pi over 4 and up 1. Okay, and my amplitude does not change. My amplitude is still the absolute value of negative 1, which is 1. So we're going to put our axes in. The period is pi, so my scale is going to be pi divided by 4, which is just pi over 4. So I'm going to mark pi over 4, pi over 2, 3 pi over 4 pi, and I'm going to need one more. I'm going to need 5 pi over 4. I start right pi over 4, so I'm going to start here. And I'm going to end after 4 spaces. 1, 2, 3, 4. My maximum is going to be 1 above the midline because that's my amplitude. And my minimum is 1 below the midline. And my graph will happen in here. Normally, sine is midline up, midline down, midline, but it has flipped. So it's going to be midline down, midline up, midline. And you want to sketch it in. Okay, we're going to graph a couple real-world applications next. This equation looks kind of crazy, but we're going to make it work. You can see the plus 65 moves the whole equation up 65. And then the minus 1 moves the whole thing right 1. So I'm going to start with my midline at 65. And the whole thing starts right 1, so it's going to start over here. Alright, the negative is a flip, and my amplitude is 25. So my maximum will be 25 above 65, so it will be at 90. And my minimum is 25 below 65, so that's at 40. So all the temperatures in this city are between 40 and 90 degrees. Okay, let's see if we can figure out our scale. Now our period is 2 pi divided by pi over 6, which is 2 pi times 6 over pi, which is 12. So that means the length of this graph is 12 months. If I start at 1 month, it's going to end at 13 months. And if I divide 12 by 4, my scale will be 3 months, meaning the important points will happen every 3 months. So starting at 1, I'm going to add 3 to that, and I'll have an important point here at 4. Add 3 to that, I'm at 7. Add 3 to that, and I'm at 10. Okay, so my cosine graph will normally start above the midline, but I'm going to start below the midline because of the flip, then to the midline, to your maximum, midline, and minimum. Your rainbows this time are upside down, and the bowl is also turned upside down. And now you can see how the temperature in this city is varying from 40 degrees up to 90 degrees and back down to 40 degrees over the course of 12 months. Okay, last problem. Here's another Ferris wheel. This Ferris wheel has another flip, an amplitude of 20, the period is going to be 2 pi divided by pi over 15, which is 2 pi times 15 over pi, which is 30. So their period is 30. The plus 10 is going to shift your whole graph to the left 10. And to figure out your scale, we're going to do that the scale is 30 divided by 4, which is 7.5. That's kind of an awkward scale. We're going to have this tick mark be negative 7.5. 0, positive 7.5, 15, 22.5, and 30. Now we're shifting back 10. So when I shift left 10, to think about 10 and this one here, which is negative 15. So if I split this block into 3, 1, 2, 3, negative 10 would land right here. So it's a third less than that block. So all of my important points are going to happen 1/3 less. So I need a point for negative 10. Let me make my midline and my upline and my downline. So I didn't actually shift up or down. So my midline stays on the x-axis. And my upline is going to be 20 above that. So I need to decide where 20 is. I'm going to count 5, 10, 15, 20. So here's my 20. And then I need negative 20. 5, 10, 15, negative 20. I'm starting back here at negative 10. And since I know my period is 30, if I add 30 to negative 10, I'm going to end over here at 20. Okay, so this is a negative cosine. It's going to start low. And then every point is going to go a little bit before the tick mark. So the next one's going to go here. And then this one is going to go here. This one goes here. And then this one goes on the line right here. And make sure you show your curvature on your cosine. And just like in yesterday's lesson, you can see how the height of the car on the Ferris wheel is going to go up and go down following a cosine curve or a sine curve.